In the beginning, the earth was silent, a restless planet waiting to breathe. From that first whisper of life in ancient seas to the rise of creatures that dream, this is the story of how existence learned to change, to adapt, and to endure. Hello there, and welcome to the Late Night Scientist channel. Tonight, we'll drift through billions of years of evolution, watching life invent itself again and again. From single cells to forests, from scales to feathers, from fins to hands. A calm journey through deep time, where every heartbeat, every leaf, and every breath reminds us that the story of life is still being written. In the beginning, there is no sound. The planet turns slowly beneath a red, swollen sun, wrapped in a haze of steam and volcanic breath. The sky is copper and charcoal, thick with the perfume of chemicals that sting and glitter in the heat. Lightning claws through clouds of methane and ammonia, striking boiling seas that hiss and recoil like startled animals. The young earth is restless, beautiful in a violent way, alive only in movement, not yet in biology. It is hard to call this chaos home, and yet, everything needed for life is already here. Carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. 6 simple ingredients waiting for a pattern. The oceans are still too hot for comfort, but cool enough for chemistry to dream. Every drop carries billions of molecules colliding, breaking apart, and rejoining in endless combinations. It is not creation in a sudden flash of genius, but patient repetition. Nature, it seems, is running a cosmic experiment, though it has no hypothesis and no intention, only time. Volcanoes tower like breathing mountains, exhaling carbon dioxide and sulfur gases into the young sky. Each eruption feeds the air with nutrients that drift and settle into the sea. In the absence of life, even rocks participate in a kind of conversation. Elements leach into water, react with minerals, form new compounds, and dissolve again. The planet, still cooling from its fiery birth, is stirring its first pot of chemical soup. One might say Earth is cooking, but without a recipe, and certainly without supervision. The surface changes constantly. Comets crash into the oceans, delivering both destruction and generosity. Each impact vaporizes water, but also sprinkles it with amino acids and organic dust carried from the ancient dark between stars. These cosmic messengers are both battering rams and care packages. With every impact, the ingredients of life become a little more complex, a little more abundant. What looks like chaos is, in truth, opportunity disguised as violence. In the shallows, where sunlight glows faintly through a haze of volcanic dust, the first fragile networks of molecules begin to form. They are not alive, not yet, but they flirt with the idea. Chains of carbon link into spirals and loops. Some of these loops accidentally copy themselves, poorly at first, but often enough to persist. The line between chemistry and biology blurs, like a horizon seen through heat. What will become life begins here, in this quiet threshold where matter learns to behave in ways it never has before. The ocean floor is another world entirely. Black vents spewing mineral-rich water into the cold deep. Around them, shimmering fields of crystals grow, dissolving and reforming in strange cycles. The contrast of heat and chill, of chemical richness and flow, creates pockets of stability where molecules can linger long enough to meet and connect. If life were to have a birthplace, this might be it. A furnace at the bottom of the sea, where the planet's inner fire meets its outer calm. Nothing breathes yet, but gases begin to balance. The atmosphere thickens with carbon dioxide, methane, and water vapor, trapping warmth and dimming sunlight. Storms are frequent, oceans churn endlessly, and yet beneath this apparent turmoil, something steady unfolds. Energy flows from sunlight, from the Earth's own molten heart, from the lightning that stitches sky to sea. In time, these flows will sustain metabolism, growth, and thought. But for now, they simply prepare the stage. Imagine this world not as hostile, but as earnest. It is doing its best with what it has, like a young artist experimenting with color and form, unsure what it's painting. Every reaction, every unstable molecule is a small experiment, a test of possibility. One day, some combination will work. A bubble that doesn't collapse, a molecule that replicates, a reaction that feeds on energy instead of wasting it. The moment it happens, life will no longer be a future event. It will be here, claiming space quietly, without permission and without fanfare. And yet, even before that first cell arrives, Earth itself behaves like a living thing. It cycles heat, moves materials, recycles gases, and responds to internal and external changes. It is, in essence, practicing. The crust fractures and drifts. The oceans rise and fall. The atmosphere thickens and thins. A restless rhythm that will continue for billions of years. This chapter of existence ends not with the first cell, but with readiness. The planet has stopped burning long enough to cool, has calmed long enough for stability, and has balanced itself finely enough that fragile molecules can survive their own ambitions. If Earth had lungs, this would be the moment it inhales for the first time, gently, experimentally, tasting its own potential. The silence is not empty anymore. It hums with reactions too small to see, but vast in implication. In every ripple, in every charged droplet, something improbable is rehearsing persistence. The next act will begin soon, one that transforms mere chemistry into the simplest form of survival. Life is coming, not as a miracle, but as a natural consequence of patience. Perhaps somewhere in those ancient tides, the first cell is already forming, holding itself together just a little longer than it should. And in that moment of unlikely endurance, the story of evolution begins. The ocean is quieter now, not calm. Nothing on the young Earth ever truly is, but quieter in its rhythm. The heat still swells from beneath the crust, and lightning still traces veins of energy across the clouds. But something has changed beneath the waves. The chaos of molecules that once collided at random is beginning to find structure. The sea is filled with whispers of chemistry attempting something new: endurance. Within the warm shallows, oily bubbles form where minerals meet organic molecules. Each droplet is a fragile globe, thin, shimmering, always seconds from breaking. Yet within their delicate walls, something remarkable is happening. Reactions that once scattered through the open sea are now trapped together, forced to interact in repeating patterns. It's the first hint of order in a disorderly world. Life, in its earliest draft, is simply the art of not falling apart. These primitive bubbles, known as protocells, are not alive by our standards. They do not think or move with purpose, but they perform something astonishing. They create an inside and an outside. For the first time on Earth, there is a distinction between self and everything else. Inside the bubble, molecules linger long enough to form cycles, reactions that feed one another, store energy, and occasionally repair damage to the membrane that keeps them contained. It is accidental maintenance, but it works. The ocean cradles billions of these fragile attempts. Most burst almost immediately, their contents spilling back into the sea, indistinguishable from all the other chemistry adrift there. But every so often, one holds together long enough for a reaction to strengthen it. Maybe a fatty acid aligning more tightly, or a charge difference that helps repel what would break it apart. These tiny victories accumulate over time, invisible yet unstoppable. Survival begins, not with strength or speed, but with stubbornness. Within some protocells, certain molecules start copying themselves. Simple strands of RNA, the first molecules capable of self-replication. It is an awkward, error-prone process, but errors turn out to be useful. Each mistake introduces a slight variation, and some of those variations make replication faster or more stable. Natural selection doesn't yet have bodies to sculpt, but it already has templates to refine. The first whisper of heredity stirs beneath the waves. As these protocells continue their chemical dance, some learn to harness energy from their surroundings. Sunlight filters weakly through the haze above, but there is energy enough in the reactions around hydrothermal vents and in minerals dissolved in seawater. Molecules inside the protocells begin to store this energy in chemical bonds, small batteries powering the fragile machinery of survival. There is no grand design here, only reactions that accidentally persist because they work better than their alternatives. If we could watch this world unfold, it would not look like a miracle. It would look like patience rewarded. Millions of tiny spheres drifting, merging, dividing, collapsing, reforming. Occasionally, one remains whole long enough to pass its structure forward, to make another bubble that behaves the same way. This is replication in its most primitive form, not birth, but continuity. Over time, the most stable protocells evolve into the first true cells. Their membranes thicken, becoming more selective, letting in what helps, keeping out what harms. Inside, the reactions grow more organized. Molecules begin to specialize. Some carry instructions, others build new parts. Others generate the energy to keep the whole system alive. This is the dawn of metabolism, the gentle heartbeat of chemistry sustaining itself. Earth itself seems to conspire in their favor. Tides mix nutrients, vents provide warmth, and minerals serve as catalysts for the reactions that sustain these young forms. Life does not emerge in a single place, but in countless microhabitats where conditions hover between chaos and calm. Wherever the balance is just right, cells appear, simple, single, and endlessly replicating. They are fragile, but their numbers make up for it. The ocean becomes crowded with persistence. To imagine one of these first cells is to picture simplicity at its most determined. A sphere of fat and water, a strand of RNA floating inside, a few basic reactions cycling endlessly. It has no senses, no mouth, no plan. It survives purely by existing a little longer than chance would expect. And yet, in that persistence, everything changes. The planet that once only moved is now inhabited by something that can remember what works. Replication brings variation. Variation brings competition. Soon, some cells absorb energy more efficiently than others. Some divide faster or seal themselves tighter against destructive surroundings. There is no malice in this competition. No predator, no prey, only trial and error. Those that endure leave descendants that resemble them. Those that fail dissolve back into the ocean's chemistry, their components recycled into the next generation of attempts. The ocean begins to shimmer with invisible purpose. Microscopic life, countless and unseen, fills every pocket of water that can sustain it. To the naked eye, nothing has changed. The same restless waves, the same drifting mists, but the balance of the planet has shifted forever. For the first time, Earth contains something that can change itself over time. In these single cells lies every future possibility. Plants, animals, intelligence, curiosity. None of it exists yet, but the foundation is in place. The membrane, the metabolism, the coded instructions, these are life's trinity of persistence. They will evolve endlessly, but the essentials are already here. If life had a motto at this stage, it might be, keep the inside in and the outside out. It sounds simple, almost trivial, yet that boundary defines everything to come. From this thin separation grows all complexity. The difference between chaos and organism, between chemistry and history. And so the world begins its quiet transformation. The ocean that once boiled with random reactions now hums with living rhythm. The first cells drift and divide, leaving traces of themselves in every corner of the sea. They do not know it, but they have succeeded at the most difficult task in the universe. They have learned how to stay together. The newborn biosphere is now a sea of invisible triumphs. Countless cells drift through the dim blue water, each one a bubble of determination, a world unto itself. There are no forests, no coral reefs, no footprints yet pressed into sand. The planet is ruled entirely by the small and the simple, and for billions of years, that simplicity is enough. Life's story pauses here, not in stillness, but in steadiness. Every drop of ocean is a city. Cells cluster around minerals rising from the ocean floor, feeding on iron and sulfur, exchanging molecules as casually as neighbors swapping stories. Bacteria and archaea, though ancient and tiny, are endlessly inventive in the quiet chemistry of survival. They form mats on rocks, build films over sediments, and fill every thermal vent and tidal pool. To them, the planet is vast, and time is plentiful. Evolution does not rush when it has the luxury of patience. The early oceans are cloudy with life but silent to the senses. A thin layer of microbial mats spreads across the sea floor like living felt, thick and slippery, pulsating with unseen traffic. Beneath each mat, bacteria cooperate in invisible hierarchies. Some consume light, some digest chemicals, and others handle the waste, recycling it into nourishment again. It is a planet-sized metabolism, each microbe a single pulse in an enormous, slow heartbeat. Above them, the sun filters through a haze of volcanic gas and water vapor, its rays muted and red. But in this dim light, certain microbes begin a quiet revolution. Using sunlight as fuel, they capture carbon from the air and release oxygen as a byproduct. The process, photosynthesis, is still primitive and dangerous, not because it harms them, but because it changes the planet itself. Oxygen, though vital to us now, is a reactive and ruthless gas. It corrodes what it touches, reshaping chemical landscapes that had been stable for eons. At first, oxygen gathers only around the cells that create it, forming tiny bubbles that vanish as quickly as they appear. But slowly, steadily, it accumulates. The oceans start rusting. Iron dissolved in the seawater reacts with oxygen and falls as mineral snow, coating the seafloor with bands of reddish rock. Over millions of years, these layers will harden into vast iron formations, the first visible fingerprints of microscopic ambition. While the oxygen makers, cyanobacteria, quietly transform the atmosphere, other microbes resist the change. Many find oxygen toxic and retreat to places where it cannot reach: deep sediments, volcanic vents, or the underbellies of rocks. There they continue their own forms of metabolism, thriving in darkness on sulfur, methane, or hydrogen. Earth becomes a world of zones, some rich in oxygen, others defiantly free of it. Diversity blooms not from size or shape, but from chemistry itself. Bacteria and archaea evolve to fill every chemical niche imaginable. Some harvest energy from light, others from the heat of the earth, and others from sheer ingenuity. Archaea in particular become masters of extremes, flourishing in boiling pools, freezing brine, and acidic springs. Their resilience is astonishing. Where conditions seem impossible, microbes quietly persist, as if to prove that impossible is simply an opinion held by larger creatures not yet born. Over time, microbial communities knit the planet's surface together. Their mats trap sediments, forming layered mounds called stromatolites. Beautiful, slow-growing structures that rise like domes from shallow seas. Each layer records a generation of growth, a calendar written in calcium and time. Long before fossils of bones or shells, These rippling patterns are the first architecture of life, constructed by beings too small to see but too numerous to ignore. Above and below, the atmosphere begins to shift. Oxygen creeps upward, thinning the planet's haze. Methane, once abundant, dwindles, and with it, the planet's warmth. The air cools, the oceans darken, and ice begins to form even near the equator. The first great ice age descends, and much of life retreats beneath frozen surfaces. Yet even this does not end the microbial reign. Beneath the ice and hydrothermal cracks, in the sediments of the sea floor, the cells continue, unchanged, unbothered, and enduring. This world of microbes lasts almost 2 billion years, an empire of time beyond imagination. From our distant view, it might seem uneventful, but within these eons, every major pattern of life is being rehearsed. Cooperation, competition, adaptation, resilience. Microbes trade genes with one another, sharing solutions as if evolution were a communal project rather than a solitary struggle. Innovation spreads laterally, sideways through the web of life, not vertically through lineage. Evolution, at this stage, is a conversation conducted molecule by molecule. The planet's chemistry becomes inseparable from its biology. The air, the rocks, the water, all carry the signatures of microbial activity. They breathe through the atmosphere, digest through the soil, and weave minerals into new forms. The earth itself is beginning to behave like a living organism, regulating temperature, atmosphere, and cycles with microbial precision. Every rock weathered, every molecule rearranged, owes something to the persistence of these small architects. It is tempting to call this age simple, but that would be unfair. Simplicity here hides sophistication. Each microbe is a chemical genius, an adaptive experiment that has already solved the hardest problems of existence. How to use energy, how to reproduce, how to endure change. For all our future complexity, we will never escape these ancient rules. The human cell, in its quiet machinery, still hums with the logic of bacteria. We are, in every sense, their continuation. And so the earth turns slowly under its microbial sky, patient and content. The great creatures, the forests, the wings and bones, all of that lies far ahead. For now, the planet belongs to the smallest and the most enduring. They are the silent custodians of time, weaving the groundwork for everything to come. Billions of years pass, and still they thrive. To them, there is no waiting, only existing. To us, it will look like the long inhale before life takes its next step. Soon, cells will begin to join forces, learning cooperation and complexity. But before that leap, the world must spend its ages in the care of the microbes, those quiet, tireless chemists who built the first stable home for life. At first, it seems like a quiet improvement. Sunlight, once only a gentle warmth on the surface of the sea, is now being captured and stored by certain microbes in elegant chemical loops. They sip carbon dioxide from the water and exhale oxygen as waste, tiny size invisible to the naked eye. No one could have guessed that these sighs would soon rewrite the planet. Photosynthesis begins modestly, the way all revolutions do. Cyanobacteria, small blue-green cells with a knack for turning light into energy, spread through the shallow seas. To them, sunlight is simply a new energy source, another trick for survival. But in harnessing it, they stumble upon something immense, a way to feed themselves from abundance, needing little more than water, light, and minerals. Life, which had once depended entirely on chemical reactions near vents and rocks, now feeds on the sky. At first, the oxygen they release dissolves harmlessly into the water, quickly reacting with metals and gases. Iron is the first to take the hit, rusting into crimson flakes that settle onto the seafloor in slow, rhythmic drifts. Over millions of years, these flakes will harden into ancient ironstone, a geological record of the world's first pollution event. The oceans turn from greenish-gray to rusty red, their chemistry forever altered by the unintended generosity of photosynthesis. For the cyanobacteria, this is progress. For almost everything else, it is disaster. Oxygen is a reactive, hungry gas, an uninvited guest at the chemical banquet of life. To the microbes that evolved in its absence, it is poison. It tears apart fragile molecular structures, destroys proteins, and corrodes the delicate machinery of ancient metabolism. The air and water that once nurtured them become toxic almost overnight on the geological clock. Entire lineages, successful for billions of years, begin to vanish. This mass extinction, sometimes called the Great Oxidation Event, is one of the most profound turning points in Earth's history. The very act of breathing, as we will later call it, begins as a crisis. The oxygen exhaled by cyanobacteria accumulates faster than the planet can absorb it. The balance tips. The seas grow hostile to their own inhabitants. The world gasps under its first global catastrophe, and life, in its first great test, learns that success can be fatal. Yet catastrophe, in the long view, is a sculptor. Some microbes adapt. They evolve enzymes to neutralize oxygen's destructive appetite, developing defenses that allow them to survive where others cannot. A few go further, turning oxygen from toxin to tool. They learn to use it as part of their metabolism, extracting far more energy from food than anaerobic cells ever could. These early oxygen users, ancestors of all aerobic life, find a new path forward, one powered by what was once poison. The planet responds to this upheaval with its own transformations. As methane levels drop, burned away by oxygen, the greenhouse warmth fades. Ice spreads from the poles toward the equator. The Earth, once shrouded in haze, becomes a glistening marble of frost. Entire oceans freeze over, locking microbial life beneath thick shells of ice. But even here, in pockets of liquid water under the frozen surface, life persists. It has learned that endurance does not mean resisting change. It means weaving through it. Under this frozen stillness, the survivors carry oxygen's lessons forward. Metabolic innovations flourish in secret. Cells evolve intricate internal machinery to handle energy with precision. The world, though quiet on the surface, is busy underneath, life reorganizing itself for the next act. The atmosphere continues to shift. With each passing eon, oxygen levels rise and stabilize, giving the sky a clearer, bluer hue. Sunlight brightens. The haze that once filtered the sun's rays dissipates, letting energy reach deeper into the oceans. For the first time, light floods the planet unobstructed, and the stage is set for more ambitious forms of photosynthesis and metabolism to follow. The planet, once choked with volcanic fumes, now smells faintly of ozone. The very air begins to protect what it once threatened. Ozone molecules forming in the upper atmosphere, shielding the surface from deadly ultraviolet radiation. Life, in inadvertently poisoning itself, has also built a planetary umbrella. It is a pattern that will repeat endlessly. Creation and destruction as twin hands shaping the world. What was once a microbial sea of sameness now holds pockets of diversity. Oxygen-tolerant organisms thrive where others cannot. Some burrow into sediments for refuge. Others rise into the light, forming new colonies that glitter beneath the waves. Evolution, freshly pressured by its own success, begins to innovate faster. The world of bacteria and archaea, once static in its comfort, has become restless. We call it the Great Oxygenation, but to the life that lived through it, it was likely less great and more unfortunate. Still, the transformation it unleashed is profound. The atmosphere changes from suffocating to breathable, from chemical to biological. The oceans, once rich in iron, grow clear and blue. Rocks, newly exposed to air, begin to weather differently. The entire surface of the earth participates in the chemistry of life, and in the long quiet that follows, the survivors, those tenacious cells that learn to coexist with oxygen, slowly reclaim the oceans. They inherit a world of open niches, a fresh canvas for experimentation. From them will come more complex partnerships, more intricate cells, and eventually, the very ancestors of all multicellular life. The great oxygen mistake, as we might gently call it, was not truly a mistake at all. It was an accident of chemistry that forced life to evolve resilience, adaptability, and creativity. In trying to feed themselves, the cyanobacteria reshaped their planet and defined the limits of endurance. Evolution learned an early and important lesson. Even catastrophe can be fertile ground for possibility. And so the ice begins to melt. The seas breathe again. And a faint shimmer of complexity spreads through the water. The world that once favored simplicity is about to reward cooperation. Soon, cells will begin to join forces, not just to survive oxygen, but to thrive because of it. The age of partnership is coming. The oceans, once rust-red with oxygen's aftermath, have quieted again. The ice retreats. Sunlight reaches deeper through water now cleared of haze and iron, and what it touches is an invisible revolution. Life, small and single-celled, has survived its first planetary crisis, and in doing so, it has grown clever. The old way of living alone, of sealing off one's chemistry from the rest of the world, still works. But now, something new begins to stir beneath the surface. The idea, if life could be said to have ideas, that sometimes it is better not to go it alone. In a microbial world driven by endless trial, certain cells begin to form unusual partnerships. One cell slips inside another, not as an invader, but as an experiment. Perhaps it happened by accident, a predator engulfing prey that refused to be digested. Inside the host, the smaller cell survives, not as a meal, but as a tenant. Over time, the two grow accustomed to one another's presence. The host provides protection and nutrients. The guest provides energy. What begins as intrusion becomes cooperation. The first uneasy roommate arrangement in biological history is underway. This is endosymbiosis, and it will change everything. The engulfed cells are ancient bacteria capable of using oxygen efficiently, a skill their hosts lack. Trapped inside their new home, these bacteria continue to generate energy, releasing it into the host's cytoplasm. For the host, this is a windfall. For the guest, it is stability. Over countless generations, what began as mutual convenience evolves into dependency. The two can no longer live apart. The smaller cell becomes the mitochondrion, the powerhouse of a new kind of organism, the eukaryote. It's not the first time life has merged, but it's the first time the merger becomes permanent. The boundaries blur, and evolution, ever opportunistic, begins to sculpt around this new architecture. The once simple cell now carries internal compartments, small rooms where reactions occur in order and safety. Nuclei appear, wrapping genetic material in protective membranes. Within this new organization, complexity finds room to grow. The eukaryotic cell is born not from domination, but from accommodation. Elsewhere, similar partnerships form between different lineages. Some eukaryotic cells take in photosynthetic bacteria, allowing them to harvest sunlight directly. These endosymbionts will one day become chloroplasts, turning their hosts into the ancestors of algae and plants. Once again, what starts as ingestion ends as intimacy. Life, it seems, thrives best when it learns tolerance. These early eukaryotes drift through the water like small universes, tiny worlds within worlds. Each one contains layers of cooperation, mitochondria humming with chemical energy, nuclei guarding coded instructions, and membranes maintaining peace among the bustling inner population. Complexity doesn't appear with fanfare. It emerges quietly, as an accumulation of agreements. Every component that survives has learned the same lesson. Harmony is efficient. The ocean floor becomes a museum of this slow transformation. In microbial mats, eukaryotic cells begin to outnumber their simpler cousins. They are larger, slower to divide, but astonishingly adaptable. Some feed on sunlight, others on organic debris, others on each other. Their energy stores, powered by mitochondria, allow them to sustain more elaborate machinery, flexible membranes, internal skeletons, and the ability to change shape. Evolution, after billions of years of perfecting simplicity, is now experimenting with complexity for the first time. But complexity comes at a cost. The new cells require balance. Too many internal reactions, and they overheat. Too few, and they stagnate. The eukaryotic strategy is one of careful moderation, of systems managing systems, like a government made of molecules. The DNA housed within the nucleus must coordinate with the DNA left inside mitochondria, remnants of their bacterial past. Miscommunication can mean collapse. And yet, for all its fragility, this arrangement works astonishingly well. The payoff is flexibility, the ability to specialize, to innovate, to explore entirely new modes of existence. From these versatile cells arise new behaviors. Some learn to move with whip-like tails, gliding through the water in search of sunlight or prey. Others develop senses for chemical gradients, able to detect food or danger from afar. For the first time, the single cell becomes a stage for awareness, still mechanical, but eerily purposeful. They are no longer at the mercy of their environment. They are beginning to navigate it. This world of emerging eukaryotes is not one of grand battles or conquest, but of quiet flourishing. In the dim, nutrient-rich shallows, colonies form loose associations, cells that stick together after dividing, cooperating in feeding and defense. It is not yet multicellularity, but the rehearsal for it. The idea of many becoming one is spreading through evolution like a rumor waiting to be believed. And all of it stems from that first act of coexistence. A cell choosing to live with, rather than consume, another. In a universe that often rewards aggression, life on Earth begins to prove that cooperation can be just as powerful a strategy. Every mitochondrion within every cell, even within our own bodies today, is a descendant of that first peace treaty signed in the depths of time. Over the next hundreds of millions of years, eukaryotes will diversify into astonishing forms, slime molds that think without brains, algae that turns sunlight into color, and protozoa that behave like miniature animals. But for now, the story remains microscopic, humming quietly beneath the waves. The planet's future complexity rests on these delicate partnerships, each one a pact between former strangers. If evolution has a sense of irony, it is this. The greatest leap in life's history comes not from invention, but from diplomacy. The first complex cells do not conquer their world. They negotiate it, molecule by molecule, until coexistence becomes indistinguishable from identity. And as the eukaryotes drift through the water, glowing faintly under the deep light, the stage is being set for yet another transformation. Soon, cells will stop merely sharing space. They will begin sharing purpose. Cooperation, having proven itself inside the cell, will soon extend beyond it, binding many into one body. The oceans have grown gentle again. After ages of chemical warfare and microbial innovation, the waters settle into a long, blue stillness. The sunlight that filters through is softer now, its golden touch reaching down into the upper layers of the sea, where life, still small, begins to gather into new shapes. It is here, in this tranquil world of drifting light and shadow, that a quiet miracle begins to unfold. The single cell, once the supreme and solitary unit of existence, is starting to find company. Some eukaryotic cells begin sticking together after dividing, forming loose clusters. It is not cooperation yet, not fully. More like proximity that happens to work. But within these temporary alliances, something remarkable takes root. The cells start to specialize. One handles movement, another senses light, another absorbs nutrients. Division of labor, so ordinary to us, emerges here as a radical experiment. In these clusters, evolution is testing a question that will shape all of future biology. What if staying together makes survival easier? The seas of this time, roughly 600 million years before the present, are soft and quiet. The continents are barren, the skies clouded with haze, but the oceans are alive with invisible promise. These early multicellular beings float through calm waters like drifting lace, delicate and transparent. Some are sheets of cells waving gently in the current. Others are hollow spheres rolling slowly through the light. Their bodies have no bones, no shells, no edges, just fluid membranes holding together by mutual agreement. To look upon them, if we could, would be like watching living veils, ribbons of tissue curling and bending, shapes forming and dissolving in the same breath. They are not yet animals as we would know them, but something before animals. Soft experiments in structure, the prototypes of form. Inside each organism, the first primitive tissues begin to emerge. Cells communicate using faint chemical whispers, aligning their efforts toward a shared rhythm. Some gather at the surface, protecting the group from changes in salinity or temperature. Others sink toward the center, focusing on digesting food or reproducing. These differences mark the first steps toward true specialization, the architecture of complexity. A multicellular body is not a random collection of parts. It is a community with a plan, however simple. The ocean floor, once dominated by microbial mats, now becomes a nursery of variety. Sheets of multicellular life creep across sediments like thin carpets of color, absorbing nutrients and light. Others attach to rocks, waving filaments into the current to capture organic matter. There is no rush to move, no need to flee. The world has not yet learned fear. Predation, the great driver of innovation, has not yet entered the scene. Here, in this brief and peaceful chapter of life's history, form evolves for curiosity's sake. Some organisms begin to fold in on themselves, forming channels and chambers where water flows freely. These internal spaces allow cells deep inside to access oxygen and nutrients. The simple act of folding, a crease in a living sheet, sets in motion a revolution of design. The first tissues become the first organs, and structure gives rise to function. What begins as geometry becomes anatomy. The environment encourages patience. Nutrients drift steadily, temperatures change slowly, and the oceans remain stable for millions of years. Evolution takes its time, fine-tuning cooperation, strengthening adhesion, refining communication. Cells begin to evolve systems for recognizing one another, distinguishing self from stranger. This ability, so vital to immunity in the far future, starts here as a kind of social contract, a way to keep harmony in the crowded interior of a growing body. With no predators to disturb them, these early multicellular forms spread widely. Some glow faintly in the dim light, bioluminescent whispers drifting through the depths. Others lie still on the seabed, forming strange leaf-like shapes that sway gently with the current. This is the Ediacaran world, a realm of softness and peace where evolution paints in translucent strokes. It is an age of exploration, but not in the sense of movement. The exploration is internal, a testing of organization, a discovery of complexity. The ocean is filled with experiments in being. Some will succeed, leaving faint impressions in ancient mud that will harden into the oldest animal fossils. Others will vanish without a trace, their lineages ending not in failure, but in contribution. Every form, every fleeting design leaves behind information that evolution carries forward. Slowly, the multicellular body begins to show signs of coordination. Waves of contraction ripple across surfaces, cilia beat in unison. Chemical signals pass from one cell to another. Movement, once individual and aimless, becomes collective and graceful. These are not yet creatures that think, but they respond to light, to touch, to change. In their soft simplicity lies the foundation of sensation itself. The world they inhabit is quiet, but not static. Currents shift, climates drift, and oxygen continues to enrich the seas. This growing abundance of oxygen allows larger bodies to exist. Life can now afford the energy costs of complexity. Multicellular organisms begin to grow bigger, bolder, more intricate. Size for the first time becomes an advantage, but with size comes visibility, and visibility in nature is always an invitation. Somewhere in these calm waters, a few cells begin to explore new ways of feeding, ways that involve consuming other living things. The peace of the Ediacaran seas will not last forever. The era of soft forms and gentle coexistence is drawing to a close. For now, though, the ocean drifts in luminous calm. Beneath its waves, the architecture of life is being invented quietly, gracefully, without conflict. Soft bodies pulse in the currents, their cells working together with patient precision. The planet is learning the art of building itself from the inside out. Soon the stillness will break. Shapes will harden, movements will quicken, and the first eyes will open. But before that turbulence begins, the earth enjoys its long, serene rehearsal, a time when life's greatest innovation was not how to fight, but simply how to stay connected. The world awakens. After millions of years of calm, the oceans that once whispered now hum with new tension. The long Ediacaran peace, the age of gentle drifting and quiet forms, begins to dissolve, replaced by something wilder. The sea floor, once a soft meadow of placid organisms basking in filtered light, becomes a stage for invention. In a geological heartbeat, evolution accelerates from a stroll to a sprint. The Cambrian period has begun, and life, for the first time, is wide awake. It starts with movement. Until now, most organisms have lived attached to surfaces or floated passively with the current. But in these new seas, some creatures begin to push, crawl, and burrow. Their bodies are no longer content to let the water carry them. Muscle-like fibers tighten and release, propelling soft bodies across sediment. The ocean floor, once smooth, now bears trails, tiny furrows carved by the first explorers of the benthic world. Motion, once a luxury, becomes a language. To move is to decide. With movement comes complexity. Creatures begin to need direction, to know where they're going and what's around them. From this simple necessity arises one of evolution's most transformative gifts: vision. At first, it is only a patch of light-sensitive cells, able to distinguish brightness from darkness. But even this small advantage changes everything. To sense the light is to sense opportunity, to find food, to flee danger, to navigate. Within a few million years, those light patches deepen into cups, then into true eyes, lenses forming from layers of transparent tissue. The oceans, once inhabited by blind wanderers, are suddenly filled with watchers. And where there are watchers, there are hunters. Predation enters the evolutionary stage like a spark landing in dry grass. It ignites an arms race that will shape the future of life forever. The first hunters are small, soft-bodied creatures armed with simple, grasping limbs or toothed mouths. Their prey, until now defenseless, must respond or perish. Some grow tougher skins, others burrow deeper. Skeletons, once unnecessary, become shields. Calcium carbonate hardens into armor, into shells, into spines. The age of soft bodies gives way to the age of skeletons. In mere tens of millions of years, a blink of geological time, every major animal body plan appears. This sudden diversification, known as the Cambrian explosion, is not truly an explosion, but an eruption of possibility. Evolution is experimenting with every conceivable shape: worms with bristles, shrimp-like swimmers with grasping claws, spiny discs gliding along the seabed, and creatures so bizarre they seem born from dreams rather than DNA. Trilobites march across the sediment like armored caravans. Anomalocaris, with eyes like clusters of gemstones and jaws like circular saws, patrols the open water as one of the planet's first apex predators. For every new innovation, there are a dozen failed experiments, designs that will vanish without a trace. Evolution is not careful at this stage. It is exuberant. It tries everything. Too many legs, too few, eyes on stalks, mouths on undersides, spirals and ovals and feathery fins. The ocean becomes a living workshop. Some creatures are elegant, others awkward, but all are expressions of the same fundamental drive: to explore what is possible within the rules of biology. The seafloor transforms into a layered ecosystem. Burrowers churn the sediment, mixing nutrients and oxygen into it, turning it into fertile ground for microbial life. Grazers feed on these mats, leaving trails like script across the mud. Predators follow, tracking scent and vibration. For the first time, Ecosystems form with distinct roles: producers, consumers, scavengers. The balance of energy and survival becomes intricate, and with intricacy comes resilience. Life is no longer a handful of forms scattered in the sea. It is a network, a web of relationships held together by pursuit and escape. The Cambrian oceans glitter with innovation. Some creatures develop external skeletons that act as both armor and support, enabling larger, more complex movements. Others evolve internal structures that give strength without rigidity. Fins, flaps, and appendages multiply, each a new solution to the puzzle of motion. The diversity of limbs is staggering. Spikes, paddles, hooks, and fans, each evolved from the same simple principle. Movement gives life choices. Vision, meanwhile, continues to advance. Compound eyes emerge, capable of detecting edges, motion, even color. Predators gain precision. Prey gains warning. Light, once only a source of energy, becomes information. The ocean fills with the silent dialogue of perception, chases, feints, and evasions playing out in the dim, blue-lit shallows. The first great biological drama unfolds without sound, without thought, yet with consequences that will echo across all of evolution. For the first time, the Earth's surface bears traces of fear. Prey dig deeper burrows. Predators grow swifter. Every advantage demands a countermeasure. Shells grow thicker, claws sharper, eyes larger. The coevolutionary spiral, the endless exchange of offense and defense, has begun. It will never end. Yet not all innovations are violent. Some creatures use movement to graze more efficiently, others to find mates or new habitats. Some grow ornate spines or patterns not for defense, but by sheer accident of growth. Beauty, though not yet appreciated, begins here as a side effect of abundance. Where there is energy and variety, there is the space for ornament. The atmosphere, still building its oxygen reserves, supports this explosion of motion and metabolism. The more oxygen, the more energy. The more energy, the more ambition life can afford. Muscles strengthen, circulation evolves, and body sizes increase. From microscopic ancestors emerge animals visible to the eye. Small, yes, but undeniable. The world, once ruled by the invisible, is now shaped by creatures that leave marks. By the end of the Cambrian, the ocean is no longer peaceful. It is alive in every sense, crowded, colorful, dangerous. The evolutionary lottery has created both winners and countless losers. But the game itself has changed forever. The rules of survival have become dynamic. To endure, life must now move, sense, react. The Cambrian seas are a crucible. Out of their tumult comes every lineage that will define the rest of Earth's history. Arthropods, mollusks, vertebrates, and more. The experiment, though chaotic, has worked. Life has learned that diversity is its greatest armor against extinction. And as the trilobites march onward and the predators refine their vision, the next great transformation is already whispering in the currents. Hard shells will harden further, bodies will grow larger, and the delicate balance between predator and prey will drive evolution toward its next challenge. The ocean, once a garden of silk, has become a forge of bone and will. The Cambrian seas, once bursting with experimental life, have settled into a new kind of order, one defined by conflict. The peaceful softness of earlier ages has vanished. In its place rises a world where survival depends on innovation, and every innovation invites a countermeasure. The ocean floor is no longer a quiet neighborhood of drifting shapes, but a battlefield of strategy, invention, and escalation. Evolution, having discovered the thrill of competition, now plays its most intricate game yet. It begins, as all revolutions do, with fear. The first true predators of the Cambrian, creatures armed with claws, spines, and eyes that can see, have upended the comfortable stability of the seas. Prey that once floated passively now scramble for safety, if such a thing can be said to exist. The soft-bodied forms of earlier ages are vanishing, replaced by creatures with armor, shells, and skeletons. For the first time, the blueprint of survival is written in bone. The invention of hard parts changes everything. Until now, bodies were temporary, dissolving into the sediment after death, leaving only faint impressions. But shells and skeletons endure. Calcium carbonate and phosphate form rigid frameworks that protect vital organs and anchor muscles, allowing stronger movement and larger size. Life, for the first time, builds architecture around itself. These new structures serve many masters. For some, they are shields, defenses against claws and jaws that have grown too efficient. For others, they are weapons, reshaped into spikes and edges. And for still others, they are tools of motion, acting as levers and hinges that make swimming faster and crawling easier. The emergence of skeletons marks the moment when form becomes strategy. The seas now shimmer with armor. Trilobites dominate the seabed, their bodies encased in overlapping plates that flex as they move. They are walking fortresses, capable of rolling into tight, armored balls when threatened. Brachiopods anchor themselves to rocks, sealing their hinged shells against intrusion. Mollusks experiment with coiling their homes into spirals, tucking their soft interiors within labyrinths of calcified defense. Everywhere, evolution is learning the same lesson. Protection is survival, and survival is the mother of creativity. But no wall holds forever. As prey grows tougher, predators grow sharper. Jaws evolve from simple grasping mouths into cutting machines, lined with the first primitive teeth. Tiny mineralized ridges that grip and tear instead of merely pulling. The arrival of teeth is subtle at first, almost invisible, but its consequences ripple through the ecosystem. Teeth are reusable tools, precise and efficient, capable of turning even small predators into formidable hunters. With this innovation, feeding becomes a craft, not a gamble. Some creatures take the offensive to new heights. Anomalocarids, already ancient veterans of the Cambrian arms race, refine their spined appendages into precise instruments for grabbing and shredding prey. Other predators develop crushing mouthparts capable of breaking shells outright. In response, prey begin to thicken their armor, developing patterns and ridges that deflect attacks. It is an endless exchange, every improvement answered by another. Evolution, for the first time, resembles an arms dealer with no allegiance. Yet amid this struggle, beauty arises. Shells grow not only stronger, but more ornate, their surfaces etched with spirals, grooves, and fractal ridges. Some of these features serve a purpose, strengthening the structure or confusing predators, but others seem to be evolutionary byproducts, decorations made by the logic of growth. In the chaos of survival, art is born accidentally. The escalation between predator and prey transforms the planet's ecosystems. The ocean floor becomes layered with burrows and hiding places as creatures seek refuge beneath sediments. Some evolve camouflage, blending seamlessly into the shifting sands. Others develop sensory organs to detect vibration or chemical trails, learning to sense danger before it arrives. The arms race extends beyond the visible. It reaches into perception itself. Skeletons also open a new frontier: size. Rigid structures allow bodies to grow larger without collapsing under their own weight. Giant arthropods roam the seabed. Massive worms tunnel through the mud. The ocean, once ruled by creatures smaller than a fingernail, now hosts giants that can be seen from a distance. Size offers protection, but also demands energy, forcing life to become more efficient at capturing and using it. Thus, metabolism quickens, and with it, the pace of evolution itself. The changes are not only physical, but behavioral. Predators begin to stalk rather than ambush, learning patterns of pursuit and evasion. Prey become alert, capable of rapid, coordinated responses. The first hints of nervous systems grow more sophisticated, wiring reflexes and reactions with astonishing speed. Thought, in its most primitive form, is born from the need to not be eaten. This age of armor and aggression might seem brutal, but it is also profoundly creative. The pressure of danger forges diversity. Each ecological duel, each adaptation and counter-adaptation creates new niches, new possibilities. Some species abandon the seafloor altogether, taking to the open water, where speed and agility replace armor. Others dig deeper, exploiting the safety of sediment and the dark. Every choice leads to another evolutionary experiment, another branch on the great tree of life. By the end of this age, the seas are a mosaic of invention. Shells gleam in the sunlight that filters through shallow waters. Creatures with jointed limbs and segmented bodies crawl, swim, and burrow in synchronized choreography. Predators glide with grace, guided by senses more precise than anything the planet has yet known. Life has become mechanical, artistic, and ruthless all at once. And beneath the glittering surface, the sediment builds up with the remains of both victors and victims. For the first time, the fossil record truly begins, a story written in stone, not memory. The shells and teeth of the dead preserve their designs for eons, silent testimonies to the restless creativity of survival. The Cambrian arms race will not end here. It will evolve into new dimensions of complexity, eventually driving some creatures to seek refuge beyond the sea itself. But before that great migration, evolution still has much to refine. The skeleton, the shell, the tooth, they are not final solutions. They are beginnings. For in the quiet after each battle, the ocean continues to murmur the same truth it has always known. Every innovation is temporary. Every defense is borrowed time. And life, no matter how armored, must always keep moving. The sea has long been life's cradle, a constant, gentle medium where bodies drifted, supported, and fed. But change, as ever, stirs beneath the waves. The continents, freshly carved by tectonic motion, rise in jagged profiles above the waterline. Rain falls, rivers carve valleys, and the wind sculpts endless plains of stone and dust. To the creatures of the ocean, this new world must look vast and empty, a silence stretching from shore to horizon. Yet, in time, that emptiness will call to them. It begins with the smallest pioneers, organisms that do not yet know they are explorers. Along the edges of tidal flats, colonies of photosynthetic algae begin to creep higher up the shore, clinging to damp rocks where waves crash and retreat. Each tide leaves them exposed for a little longer, and those that can endure the dryness survive to spread further. This is how conquest begins on Earth. Not with conquest at all, but with small acts of tolerance. These early land dwellers are simple mats of green, fragile but persistent. They form thin films over wet stone, their pigments glinting beneath the sunlight. The air, though harsh, offers something no ocean ever could: limitless carbon dioxide and direct light unfiltered by water. The rewards are immense, if only life can learn to cope with the costs. Dryness is the first great enemy. In the sea, cells are bathed in comfort, but on land, water must be guarded like treasure. The algae that survive do so by wrapping themselves in waxy coats, sealing moisture inside their cells. From these humble coatings will one day evolve the first plant cuticles, the protective skins of leaves and stems. The world's first green shimmer begins to spread, not lush or towering, but in soft films that hug the ground like fog frozen in place. Roots are next, or at least their ancestors. In the shallows, filaments anchor the algae against waves. On land, those filaments begin to dig. They burrow into the soil, searching not for footing, but for moisture. The relationship between life and rock begins here. Water, drawn through mineral grains, feeding the body above. In time, these simple anchors become true roots, not just securing plants, but changing the land itself. As plants spread, they transform their surroundings. Their bodies trap dust and sediment, their decayed remains enriching the soil. Before plants, the continents were barren and eroding. After plants, they begin to grow their own skin, a living crust of mossy green. Rain that once scoured bare rock now filters through organic matter, creating mud, clay, and eventually the dark, fertile earth that will cradle forests. Life is beginning to hold the planet together. The air, too, begins to change. Plants breathe out oxygen and water vapor, thickening the atmosphere, softening the climate. The land, once dry and hostile, grows humid. Patches of green darken into carpets. From a distance, Earth now has two colors: the ancient blue of the sea and the newborn green of the land. But plants are not alone in this brave expansion. Alongside them crawl the first arthropods, the descendants of marine trilobites and crustaceans, creatures encased in armor that doubles as protection against desiccation. Their jointed legs, once used to scuttle along the seabed, now lift them across mud and sand. In their bodies, liquid circulates in sealed systems, their lungs adapted to draw oxygen from air instead of water. The insect's ancestors have arrived, and they explore this new world with the same relentless curiosity that once drove microbes across the seafloor. Their challenges are immense. Gravity presses harder here. Every movement must work against it. There is no buoyant water to cradle their weight, no current to carry them. The air, though rich in oxygen, dries them out quickly. Yet where the plants spread moisture and shade, the arthropods follow. They graze on decaying algae, sip from puddles, and find shelter in damp crevices. Step by cautious step, the web of life tightens around the land. Evolution now takes on a slower, deliberate rhythm. Each generation adjusts to air, to heat, to light unfiltered by water. Eyes evolve to see clearly in open daylight. Limbs strengthen, exoskeletons thicken, and breathing systems refine. The insect's early ancestors grow more confident, venturing farther inland, discovering an alien world of textures, sand, stone, and wind. What was once shoreline becomes ecosystem. The continents themselves begin to change under their touch. Roots fracture rock, creating soil. Burrowing arthropods mix that soil with organic matter. Streams meander differently where vegetation takes hold, shaping valleys into gentler slopes. Life is not merely adapting to the land, it is engineering it. The planet, once sculpted only by geology, now feels the fingers of biology reshaping its face. For millions of years, the land remains quiet but busy. Mosses and early vascular plants form low mats and spindly shoots, hugging moisture in every surface they can. There are no flowers, no trees, only green tapestries stretching over mud and stone. The air hums faintly with the sounds of tiny legs, the rustle of arthropods crawling among stems. It is a fragile balance, easily broken by drought or cold, but it holds because evolution has learned persistence. Eventually, some plants grow taller. Their stems thicken, their tissues stiffened by new molecules, lignin and cellulose, strong enough to resist collapse under gravity. With height comes advantage, more light, more space, more opportunity. From these upright pioneers will come forests. But for now, the land remains a mosaic of mossy flats and shallow swamps. It is difficult to overstate what has been achieved. Life, once confined to oceans, now breathes the air, touches the sun directly, and reshapes the continents. The courage to leave water is not a single event, but a slow, collective decision made by countless lineages over millions of years, each one taking a few steps further from the tide. From this humble beginning, every leaf, every forest, and every terrestrial creature will one day descend. The land, once empty stone, is awakening into a living skin of green and motion. And somewhere at the edges of this spreading wilderness, other eyes, those of fish with strong fins and curious habits, begin to look toward the shore. The plants have shown the way. The air is no longer fatal. It is only unfamiliar. The next bold travelers are waiting in the shallows, ready to rise. At the edges of the ancient seas, where sunlight ripples through warm shallows and reeds sway in gentle currents, something extraordinary is beginning to stir. For hundreds of millions of years, the oceans have been life's empire, vast, nurturing, and complete. Yet now, the boundaries between water and air are thinning. The green world of plants has conquered the land, spreading its carpets of moss and fern, and the arthropods have followed, turning the once barren coasts into thriving ecosystems. From beneath the surface, vertebrate eyes begin to watch that world with a new kind of curiosity. In the shallows live fish that are different from their open ocean cousins. They do not dart or glide elegantly through endless water. Instead, they live among reeds, roots, and mud. Theirs is a world of stillness, of murky silt and oxygen-poor water. Here, gills alone are not always enough. During droughts or in stagnant pools, air becomes their only refuge. Some fish begin to gulp at the surface, pulling oxygen into small vascular sacs inside their bodies, structures that will one day become lungs. Breathing air at first is not ambition, it is desperation. But necessity has a way of rewriting anatomy. The fins of these shallow water dwellers also begin to change. In open water, fins serve for balance and thrust, fluttering effortlessly in 3 dimensions. But near the bottom, where roots and rocks offer obstacles, movement becomes more deliberate. Fins thicken with bone and muscle, turning into weight-bearing supports capable of pushing against the mud. Slowly, imperceptibly, a new kind of limb begins to emerge. Not yet a leg, but something that can press, lift, and crawl. Evolution, like a careful sculptor, is learning the difference between swimming and walking. Among these creatures is one lineage that will leave a mark deep in the fossil record: the lobe-finned fish. Within its fins lie sturdy bones, humerus, radius, ulna, that will later echo in the limbs of salamanders, reptiles, and even humans. The pattern appears first as chance, then as destiny. These early vertebrates test the limits of their design, wriggling between pools during droughts, pushing themselves onto exposed mudflats in search of food or safety. Their eyes, once adapted to refracted light, begin to adjust to the direct glare of the sun. A new world shimmers before them, bright and disorienting. The transition is not swift. It happens over millions of years, generation by generation, each one nudging anatomy a little further toward land. Limbs strengthen, Ribs widen to support heavier bodies, and necks loosen from rigid shoulders, allowing heads to turn independently. The transformation is subtle but revolutionary. Mobility becomes precision, and motion gains purpose. For the first time, a vertebrate can look around. Those who dare venture onto land encounter a world utterly alien. The air smells different, thick with plant scents and the sharp tang of minerals. The ground is unsteady, unpredictable, offering no buoyant support. Gravity, that familiar companion underwater, now presses like a constant test. Each step is an act of rebellion against the element that once defined them. But on the shore waits a reward that no ocean can offer: abundance. The land is green and crawling with life. Arthropods skitter among mosses and towering ferns, feeding on decaying plants and each other. The skies, if one can call them skies yet, buzz faintly with early insects. For a fish that has learned to breathe air and bear its own weight, this new territory is paradise unclaimed. Food is plentiful, predators are few, and the open world stretches endlessly in all directions. The first amphibians do not yet know what they are becoming, but they are pioneers all the same. The challenges of terrestrial life remain immense. Skin that once glistened in water now risks drying and cracking. Eggs, once safe beneath the waves, would wither in the sun. But for the early land vertebrates, creatures like Tiktaalik and Acanthostega, the boundary between land and water is not a strict divide. They live in both worlds, basking in the shallows by day and retreating into cool ponds by night. They are transitional beings, neither fish nor fully terrestrial, but perfectly adapted to their in-between world. Their anatomy tells the story of compromise. Limbs strong enough to push, but still finned for swimming. Lungs that draw air, but gills that linger as backup. Eyes perched atop flat heads, designed to peer just above the surface like patient hunters. Each feature hints at what's to come. In the slow dance of adaptation, evolution rarely starts fresh. It remodels the familiar into the unexpected. The ripple effects of this migration reach far beyond these amphibian pioneers. Once vertebrates can walk, they can explore. Rivers, swamps, and deltas become highways into the interior of continents. New ecological networks bloom wherever these explorers wander, their footprints pressing life's mark into mud that will one day fossilize into memory. The earth itself responds to this change. The land, already softened by plants, begins to pulse with new rhythms, heartbeat-like tremors of movement, as vertebrates crawl across its surface. Life is no longer confined to the tides. The planet, for the first time, hosts creatures that can bridge the realms of sea and sky. These amphibian ancestors do not know it, but they are opening doors that evolution will never close. From their awkward crawls will come strides, leaps, and the soaring wings of distant descendants. From their first breath of open air will come lungs that one day fill with songs. It is easy to imagine that the first step onto land was hesitant, a half slide from the shallows, a moment's pause in the sun before retreating back to safety. But somewhere, perhaps countless times, one did not retreat. it stayed, lingered, pushed further. And in that small act of persistence, the world changed forever. Life had conquered the seas. Now, with damp fins and uncertain limbs, it had reached for the shore, and in doing so, reached for the future. The earth is warmer now, its continents knit into great, sun-baked masses of rock and sand. The swamps that once cradled amphibians stretch outward into drier plains and deserts. Rivers wind sluggishly beneath skies heavy with heat. Here, under the blaze of the Paleozoic sun, a new kind of creature begins to rise. One that will master the land not by returning to the water, but by leaving it behind entirely. Amphibians were pioneers, but they were still tethered to the damp. Their eggs, gelatinous and fragile, had to be laid in water. Their skins, soft and permeable, dried and cracked under an unforgiving sun. Each new generation remained bound to the edge of ponds and rivers, as though afraid to lose sight of their birthplace. The land was vast, but amphibians could only borrow its edges. For life to truly conquer the continents, it needed a new invention, a way to carry water within itself. That invention arrived in the form of an egg. Not the soft, exposed eggs of amphibians, but a new kind entirely, sealed, self-contained, and astonishingly independent. The amniotic egg was a miniature world, a private ocean enclosed in a shell. Inside it, the embryo floated safely, cushioned by fluid, fed by yolk, and protected from the dry air. It could develop entirely away from ponds or swamps. When it hatched, a fully formed creature emerged, ready to walk, breathe, and feed on land. This was evolution's most elegant solution yet. By enclosing its young in their own portable seas, life had broken the final chain that bound it to the water. The amniotic egg was not just a structure, it was freedom itself. Those who bore these miraculous eggs were the ancestors of reptiles, and their story would stretch across more than 200 million years. Their skins, once soft and moisture-loving, became dry and armored with scales, a mosaic of keratin that held water inside and heat outside. Beneath that skin, their physiology shifted. Lungs deepened, circulation strengthened, and muscles became engines for endurance rather than bursts of effort. These early reptiles were no longer bound to the shade. They could bask in the sun and wander across arid ground, their bodies tuned to the rhythm of heat and light. The land responded with opportunity. As amphibians retreated to the swamps, reptiles fanned out across the continents. Some remained small and swift, scuttling among ferns and moss. Others grew heavy and slow, thick-skinned giants that rumbled through forests. The variety of habitats, deserts, savannas, wetlands, became laboratories of adaptation. With each generation, life learned a new trick for dryness. Thicker scales, deeper burrows, sharper senses, or slower metabolisms. To endure the temperature extremes of day and night, reptiles perfected a simple, ancient art: thermoregulation by sunlight. Instead of burning fuel internally as mammals would later do, they let the sun do the work. Mornings were for basking, afternoons for hunting, evenings for retreat. Their very stillness became a survival strategy. While the air shimmered with heat, a lizard could pause for hours, its heart beating barely faster than the stones beneath it. In a world where energy was scarce, patience was power. Some reptiles returned to the water not out of need, but out of choice. They evolved into graceful swimmers, their limbs flattened into paddles, their scales becoming sleek. Others rose into the trees, developing claws for gripping and tails for balance. The land was theirs to divide. For the first time, the continents echoed with the sound of reptilian footsteps, soft on sand, hard on stone, a rhythm that would become the heartbeat of the Mesozoic world. And then, from these diverse lineages, came the architects of a new empire. The archosaurs, ancestors of crocodiles, pterosaurs, and dinosaurs. They inherited all the gifts of their reptilian kin: the dry skin, the sealed eggs, the efficient lungs, and refined them for domination. Their limbs rotated beneath their bodies, allowing for upright movement and speed. Their hearts grew powerful, their senses keen. Where amphibians had crept, reptiles now strode. The age of reptiles was dawning. But this age was not defined only by size or strength. It was defined by adaptability. Reptiles learned to inhabit every climate the earth could offer. Some evolved to conserve water so efficiently that they could go weeks without drinking. Others developed specialized scales to reflect sunlight or trap warmth. Their eggs could be buried in sand, hidden in soil, or warmed by the sun itself. With the amniotic egg, even deserts could host nurseries. Over time, reptiles diversified into forms that seemed almost fantastical. Long-necked herbivores stretched their heads into treetops. Predators evolved teeth like knives and legs that could chase down anything that fled. In the skies above, their cousins took flight, leathery wings catching thermals that lifted them over vast plains. The planet, for the first time, belonged to air-breathing vertebrates who did not need to look back at the sea. Through all this expansion, one trait defined them more than any other: composure. The reptiles' mastery of dryness was also mastery of stillness. Their cold-blooded nature allowed them to wait, to conserve, to endure. While other creatures lived fast and died young, reptiles perfected the art of longevity. Some might rest through entire seasons, buried beneath sand, their hearts whispering through months of drought. In the wisdom of their bodies lay a kind of serenity, survival by restraint. As the millennia passed, the Earth itself became a reptilian planet. Great forests stretched across equatorial belts, deserts shimmered at the poles, and everywhere between, scales glinted beneath the sun. The water-bound past felt distant now, almost forgotten. Life had reinvented itself to fit the heat and hardness of the land, trading fragility for endurance. And yet, evolution was far from finished. From this lineage of dry skin and patient hearts would one day rise two extraordinary branches, one that would master warmth and another that would learn to fly. But for now, the earth belongs to the reptiles, wise in their silence, calm in their confidence. their dry skin gleaming under a sun that they have learned not just to endure, but to use. The age of reptiles rolls onward in thunderous confidence. Great beasts roam across fern-covered plains, their scales glinting in the sun. The air trembles with the wing beats of pterosaurs, and the seas churn with reptilian giants. By day, the world belongs to the sunlit titans. But when the horizon fades to dusk and the heat drains from the rocks, a different kind of life stirs. In the cool hush of twilight, under stars still new to the sky, the small and the warm begin to claim their time. They are not mighty. They do not roar or tower. Most would fit in a human hand, and many could vanish into a pocket of moss. Yet within their fragile bodies burns a secret advantage: warmth. While the reptilian rulers of the day slow and slumber with the setting sun, these tiny creatures remain awake, their hearts racing, their blood alive with its own fire. This is the dawn of warm-blooded life, creatures who no longer borrow the sun's heat, but make it themselves. The earliest mammals begin their story in the shadows of dinosaurs. They are descendants of small, shrew-like synapsids, ancient reptiles who, long before the great saurians, began to experiment with faster metabolisms and more efficient breathing. Over time, their bodies transform from cold engines of sunlight to self-contained furnaces. Muscles grow rich with mitochondria. Hearts beat faster. Lungs become intricate bellows that draw in air even as they exhale. To fuel such energy, these creatures must eat constantly. But energy buys independence. They no longer wait for the sun to warm them. They carry warmth within. In this quiet, moonlit world, fur becomes the next great innovation. At first, it may have been little more than sensory whiskers or patches of insulation along the back. But soon, evolution wraps these small bodies in dense coats of hair, perfect for trapping the heat they generate. Soft and light, fur becomes both armor and blanket, an exquisite balance between protection and efficiency. Each hair is a declaration of self-sufficiency. I will make my own climate. Night after night, the early mammals scurry between ferns, digging burrows, nesting in crevices, feeding on insects and seeds. Their senses are tuned for darkness, large eyes that catch every glimmer of starlight, ears so keen they can hear a beetle shifting in the soil. Smell becomes a map, touch a compass. In a world where vision ruled the day, these small creatures master the unseen. Above them, another lineage is learning the same lesson in a very different way. From certain groups of small, feathered dinosaurs, the first birds begin to rise. Feathers, once perhaps a display of color or a means of insulation, transform into instruments of flight. Hollow bones lighten their frames, air sacs lace through their bodies, and hearts pump with relentless rhythm. Like mammals, they are warm-blooded, fueled by high metabolism and a steady internal temperature. But where mammals conquer the night, birds take the skies. Two separate paths, born of the same truth. Life thrives when it carries its own warmth. The world is now divided by temperature as much as by time. When the sun blazes, the great reptiles reign. When it fades, the mammals emerge, soft-footed, cautious, but tireless. While the giants depend on the rhythms of the environment, the warm-blooded ones dance to their own tempo. It is not power that gives them an edge, but flexibility. They can live anywhere, under snow, in desert burrows, or inside hollow logs. Warmth, though costly, grants freedom. But warmth alone is not enough. These creatures must sustain their furnaces with food, and food demands strategy. Mammals evolve complex teeth, cutting, grinding, slicing, all designed for specific diets. Some chew insects, others seeds, and others leaves. Their jaws become hinges of precision, their tongues agile instruments of taste. The reptilian bite was a simple snap. The mammalian bite becomes a craft. With warmth also comes nurturing. The young of these creatures emerge helpless and hungry, demanding care. From this dependency grows something entirely new in nature: parental devotion. Milk, another evolutionary marvel, flows from mammary glands, providing nourishment and immune protection. The bond between parent and offspring becomes a survival tool. For the first time, tenderness becomes evolutionarily advantageous. The mammal's world is one of warmth, not just in body, but in behavior. Meanwhile, the birds refine their own art of endurance. Their feathers, delicate yet strong, create perfect insulation, trapping air while allowing movement. Flight demands immense energy, and so their metabolisms burn like controlled fires. They eat constantly, hearts beating at furious speeds, lungs cycling air in continuous flow. To see a bird soar is to witness metabolism turned into motion, warmth translated into grace. Together, mammals and birds carve out a new ecological rhythm, life that never fully rests. The world, once divided into day and stillness, now beats with continuous life. Even as reptiles bask motionless under the midday sun, the air hums with avian wings, and the night rustles with mammalian activity. The earth has found its perpetual motion machine. Still, for much of this era, the small remain overshadowed by the colossal. Dinosaurs dominate every landscape, from fern forests to coastal plains. Yet the mammals endure, never challenging the giants, never drawing attention. Their success lies not in dominance but in discretion. They are the quiet survivors, swift, adaptable, and invisible. In the long twilight of the Mesozoic, these warm-blooded creatures refine their talents. They grow more alert, more social, more intricate in their senses and behaviors. Evolution, ever patient, is laying groundwork again, preparing for another shift, one that will come not with invention, but with catastrophe. For now, though, the night belongs to them. Beneath the feet of dinosaurs, under ferns that glisten with dew, tiny hearts beat fast and constant, defying the cold. Above, in the silver-blue air, feathered wings cut through the moonlight. Warmth radiates quietly from fur and feather alike, a living glow against the chill of the ancient dark. The giants sleep. the small ones dream, and in their dreaming, the future is already taking shape. For more than 150 million years, the Earth has basked beneath the reign of giants. Dinosaurs roam across continents thick with ferns and cycads. Pterosaurs glide over shallow seas, where marine reptiles hunt in silence. Mammals scurry beneath roots, birds sweep the skies, and the planet hums with life in its fullest expression. The world seems eternal in its rhythm, a living clock that will tick forever. But time, as always, keeps a quiet secret. Nothing in nature is permanent. The shift begins subtly, almost politely. Volcanic murmurs in distant lands, a gradual cooling of climate, a change in sea levels. Life carries on, unaware that its stage is about to tilt. But in the deep black of space, a stone is already falling. It tumbles invisibly for eons, drawn by gravity and chance, until one day, one bright, irreversible day, it finds its mark. The impact strikes with the violence of creation itself. In an instant, forests ignite, seas rise in walls of steam, and shock waves ripple around the globe. The dinosaurs, so accustomed to ruling the light, have no defense against the darkness that follows. Ash fills the sky, turning day to twilight. The sun, life's ancient ally, disappears behind a veil of dust and sulfur. For months, perhaps years, the world freezes under its own shadow. Photosynthesis falters, plants wither, the food chains collapse from the bottom up. The giants that once thundered across the land now stumble and fall in silence. Their massive hearts, built to sustain warmth and motion, cannot endure famine. Oceans cool, corals bleach, and the air grows thin and bitter. More than 3/4 of all species vanish into history's black ledger. It is the end of the Mesozoic, the closing curtain of the age of reptiles. But extinction, as devastating as it is, does not erase life. It reshapes it. When the dust finally settles, the survivors crawl, fly, or burrow out of the ruins. They are not the mightiest, nor the fiercest, but the most adaptable. Small reptiles, fish, insects, birds, and the modest mammals that once lived in the shadows. For them, the catastrophe is not an ending, but an opening. The world, once crowded and competitive, is now spacious and silent. Ecological niches, those countless small roles in the web of life, lie empty, waiting to be filled again. It is as if evolution, having cleared the canvas, invites its artists to begin anew. In the forests that return, small mammals scuttle through the undergrowth, feeding on seeds and insects left unchecked. Freed from the shadow of dinosaurs, they grow bolder, larger, and more varied. Some take to the trees, their limbs stretching into new shapes for climbing. Others dig into the soil, tunneling through a world of roots and earth. A few venture into open plains, where grass will one day spread like a green sea. With every adaptation, the mammals expand their claim, shaping the ecosystems that follow. The birds, too, find their new dominion. With the great flying reptiles gone, the skies belong to them alone. They diversify into an orchestra of forms: songbirds, raptors, waterfowl, each testing a new melody in the air. Feathers, once tools for survival, become canvases for beauty and communication. The sky, once filled with leathery wings, now shimmers with color and movement. The oceans recover more slowly, but recovery comes. Coral reefs rebuild, fish evolve into sleek new hunters, and marine mammals, descendants of land dwellers, begin their long return to the sea. The earth heals not by returning to what it was, but by inventing what comes next. Yet, beneath this rebirth lies a profound truth. Extinction is not simply destruction. It is the planet's way of resetting the rhythm when imbalance grows too deep. Life's story is not linear. It is cyclical, pulsing between abundance and absence. Every ending, however brutal, becomes the soil of another beginning. The mammal's rise is not guaranteed. It is earned through resilience. Their small size, rapid reproduction, and warm-blooded endurance make them ideal survivors in a cold, dim world. In the wake of loss, they learn flexibility, intelligence, and cooperation. Traits that once seemed trivial become the foundation for a new kind of success. They are no longer creatures of the night. They begin to reclaim the day. Meanwhile, the earth itself changes character. Continents drift into new positions, climates shift, and vegetation transforms. The once dominant conifers retreat, making way for flowering plants, angiosperms, that color the land with diversity and scent. These blossoms attract insects, which in turn attract birds and mammals, weaving a new web of interdependence. Evolution, after catastrophe, becomes a symphony again. Still, traces of the old world remain. Fossilized bones rest in stone like punctuation marks in the story of change, reminders that no empire lasts forever. The reptiles that once ruled the continents survive only in fragments: crocodiles in their rivers, turtles in their shells, and the birds above. Living echoes of dinosaurs turn to song. For millions of years after the impact, the earth remains both scarred and fertile. Volcanoes rebuild mountains, rivers carve new valleys. The climate warms once more, and life spills back into every corner that will have it. Each surviving lineage diversifies wildly, as if the planet itself has remembered how to breathe again. The tragedy of extinction fades into the quiet resilience of recovery. In the great ledger of evolution, this mass extinction is a reckoning, but also a renewal. It clears the stage for new actors, new possibilities. From the ashes of loss will rise creatures that think, creatures that feel, creatures that wonder. But all of that still lies in the distant future. For now, the world is quieter, smaller, simpler. The smoke has lifted, the skies are blue again, and the survivors move carefully through their changed home. The earth exhales, and in that long breath, life begins its next act, one written not by giants, but by those who endured. The world has quieted since the cataclysm that ended the reign of giants. What remains is a planet open to invention, a place of forests and plains, rivers and flowering plants buzzing with insects, birdsong, and the soft scurry of mammals. The age of scale and spectacle has given way to an age of subtlety. No creature will ever again dominate Earth through size alone. Survival now depends on something less visible, more intimate: thought. At first, intelligence is not a grand idea. It begins humbly, as the simple need to adapt in a world that refuses to stay predictable. Forests grow and vanish, climates warm and cool, predators shift and evolve. The animals that endure are those who can respond, not by instinct alone, but by choice. Nerve cells form networks that remember, that anticipate. Small mammals learn where to find food when the seasons change, how to hide their young, how to work together when danger prowls nearby. In this new age, memory is might. The brain, once a modest cluster of tissue guiding movement and hunger, begins to expand. Folds and grooves deepen, increasing surface area without increasing size. Neurons multiply, synapses strengthen. Thought, once an echo, becomes architecture. But intelligence, for all its growing complexity, is not a march toward perfection. It is a tool shaped by circumstance. In dense forests, sight becomes less useful, so smell and hearing sharpen. In open plains, vision dominates, allowing creatures to plan and stalk across great distances. Each brain evolves in conversation with its world. Among the trees, some lineages of mammals begin to climb. Life in 3 dimensions demands new coordination, a mind capable of judging distance, of planning leaps and handholds. Fingers, once claws, become dexterous and sensitive. Eyes shift forward, granting depth and focus. In these early primates, the nervous system becomes a weaver of possibilities. They learn not only to move, but to choose how to move. Their hands become instruments of imagination, capable not just of grasping, but of holding, turning, examining. Curiosity, once a danger, begins to pay dividends. Curiosity alone, however, cannot sustain a lineage. Sociality emerges as an equally powerful force. In the uncertain landscapes that follow the Great Extinction, cooperation becomes survival's most elegant solution. Small mammals huddle for warmth, warn each other of predators, and share the burden of raising young. Over time, these bonds deepen into structures of behavior: packs, troops, herds. Within these groups, communication evolves beyond sound or scent. Expression, gesture, even empathy become currencies of connection. The mind, once confined to one skull, begins to reach across many. The roots of emotion grow here too, not as luxuries, but as evolutionary necessities. Affection binds the young to their parents long enough to learn survival's lessons. Loyalty keeps groups together when resources thin. Grief, though costly, enforces the memory of loss, ensuring that danger is not repeated. Intelligence without emotion would fracture. Emotion without intelligence would stagnate. Together, they make life cohesive, capable of culture in its earliest, wordless form. Meanwhile, in other corners of the world, intelligence takes different shapes. Dolphins and whales, descendants of land mammals, return to the sea, develop vast, complex brains suited for social communication and navigation through sound. Elephants, with their long memories and communal bonds, learn to mourn their dead and guide their young across generations. Ravens solve puzzles, octopuses use tools, and ants organize colonies that behave like single superorganisms. Each expression of intelligence fits its environment as naturally as a shell fits its mollusk. Still, it is in the forests that something remarkable continues to unfold. The primate's hands, already skilled for climbing, begin to serve subtler purposes: grooming, feeding, even play. Each touch reinforces bonds. Each gesture conveys meaning. Play, once dismissed as frivolous, becomes the laboratory of the mind, a safe rehearsal for risk, a test of imagination. Through play, the young learn cause and effect, coordination, and cooperation. In this sense, intelligence is less about solving problems than exploring possibilities. The expansion of brain and hand sets the stage for creativity. Primates begin to use objects, not yet tools, but extensions of intention. A stick to probe a hole, a leaf to sip water, a rock to crack open a nut. Each act carries a small spark of foresight, a sense that the future can be shaped by preparation. When an animal looks at a stone and sees not what it is but what it could be, a threshold has been crossed. But intelligence is costly. Large brains consume enormous energy, demanding constant nourishment. To sustain them, social species develop strategies of sharing: food, shelter, vigilance. Cooperation becomes not only a defense but an investment. The mind, in turn, rewards cooperation with pleasure, reinforcing bonds through the chemistry of trust. Evolution, in its quiet genius, links survival to kindness. As the forests spread across the continents, primates diversify. Lemurs on isolated islands, monkeys in the tropics, apes in the dense canopies of Africa and Asia. Each lineage carries the same potential: minds that can plan, hands that can explore, and societies that can remember. The future, though still veiled, is already whispering through their gestures. And yet, none of this feels inevitable. Intelligence is not destiny. It is an experiment, as fragile as any other adaptation. For every clever primate, there are countless creatures thriving without thought, succeeding through simplicity. The world remains balanced between instinct and insight, between reaction and reflection. The rise of complex minds is not nature's goal. It is nature's curiosity. As evening settles over the Miocene forests, the air hums with quiet conversations of birds, mammals, and insects, all engaged in their own forms of communication, their own small intelligences. Among the branches, a group of apes gathers close, grooming one another as the day fades. The touch is gentle, the sound soft, a language older than words. In this closeness, in this simple act of care, the seeds of future consciousness lie hidden. not in tools or fire or speech, but in connection, in the understanding that survival is easier and life richer when lived together. The age of giants ended in thunder. The age of minds begins in whispers. The world as it stands now is a mosaic of everything that has ever been. Beneath our feet lie the bones of vanished empires, and in the air float molecules that once fed ancient forests. The seas still carry whispers of the first cells. The soil hums with the chemistry of eons. Every living thing, from a drifting plankton to a soaring hawk, is a continuation of the same unbroken experiment that began more than 3.5 billion years ago. Life has never stopped changing. It only changes the way it changes. The creatures that fill the earth today are not the final drafts of creation, but notes in a melody still being written. Every adaptation, every fleeting success or failure is a verse in a story that has no punctuation mark at the end. The cells that once learned to cling together now build forests and coral reefs. The genes that once floated freely in bacteria now compose symphonies of complexity in whales and flowers. Yet all of it, even the most elaborate forms, follows the same quiet rhythm: variation, persistence, renewal. Evolution does not plan ahead. It simply listens. It listens to climate, to competition, to chance. When a drought comes, it rewrites roots. When a predator evolves, it sharpens sight or thickens skin. When ice grips the poles, fur lengthens, metabolism quickens, or migration begins. The process is not wisdom in the human sense. It is responsiveness, a form of patience that operates over millions of years. And it is still happening everywhere, all at once. In city gutters, bacteria evolve resistance to antibiotics faster than we can invent them. In warming oceans, coral and algae renegotiate their partnerships, testing new chemistries for survival. In forests, plants shift their flowering times to match changing seasons, while pollinators learn to follow. Even in the human body, our cells whisper with the same ancient logic that shaped the first life: survive, adapt, persist. If one could watch the earth from afar, not for years, but for ages, it would look alive in its entirety, a breathing, self-correcting organism. Continents drift like slow thoughts, climates oscillate like heartbeats, and the living fabric adjusts in turn. Species rise and vanish not as tragedies, but as transitions. Extinction is no more an ending than birth is a beginning. Both are movements within the same continuous current. We too are threads in this vast tapestry. The hands that write, the eyes that read, the thoughts that wonder how it all began. These are not separate from the story, but part of it. The atoms that form us were forged in stars, carried through space, gathered into oceans, and reshaped by the same processes that shaped every living thing. To be human is not to stand outside of evolution, but to be one of its more reflective experiments. Yet evolution is indifferent to reflection. It continues whether or not we understand it. Species shift around us as we change the world faster than most can follow. Some adapt with startling grace. Foxes that thrive in cities, plants that grow through concrete, birds that sing new dialects to be heard above the noise of machines. Others, less flexible, fade quietly into memory. We often mistake this as progress or decline, but it is neither. It is the timeless negotiation between life and environment, endlessly revised. Even now, new forms are arising in places we rarely think to look. Deep beneath the ocean floor, microbes consume methane in the dark, building ecosystems that have never seen the sun. In steaming vents, bacteria knit metal and sulfur into living tapestries. On glaciers, algae bloom in colors that stain the snow pink. Life is as restless as ever, still experimenting, still finding ways to turn adversity into opportunity. The great tree of life, once a fragile sapling of single cells, has branched beyond comprehension. Yet it is not a tree with a single trunk, but a web that tangles, merges, and splits. The boundaries between species blur, genes drift across them, and cooperation mingles with competition in endless complexity. To look for a pinnacle of evolution is to misunderstand it. There is no summit, only an expanding landscape of possibility. What we call now is simply a cross-section of that ongoing motion. The animals of today will one day be fossils, their descendants unrecognizable to the present eye. The forests we know will change shape. The oceans will shift in chemistry and color, and entirely new ecosystems will arise in their wake. If time is a painter, then evolution is the brush that never dries, layering color upon color until every trace of the past becomes the texture of the present. And still, the essence remains: persistence. The same stubborn will that held the first cell together in a stormy sea still hums through every living being. It hums in the whale's song, in the root that splits stone, in the human pulse that beats to rhythms older than language. The story of life is not about triumph or perfection. It is about continuity. Even when the script burns, even when pages are lost, the handwriting of existence continues. One day, far from now, the earth will change again, its continents shifting, its sun brightening, its oceans perhaps receding into vapor. Life may falter, then reinvent itself once more, or pass its story onward through traces left in rock and stardust. If the universe listens, it may hear what we have all been whispering from cell to star: that existence is not a state, but a conversation. So the story does not end. It turns another page. The oceans still breathe, the forests still listen, and evolution still writes, quietly, ceaselessly, its unfinished poem across the surface of the world.